Hello and welcome to the presentation of the final solution to the challenge of predicting forced displacement of our team. The refugees crisis is a big problem worldwide. Last year, 80 million people were forcibly displaced around the world. Estimating and predicting the total number is very challenging due to rare and uncertain factors. This way, our team has developed machine learning models for time series forecasting with interpretability techniques to allow decision making and effectively respond to this crisis.
We have decided to use some of the databases that were recommended for the challenge and also some of the ones additional. More precisely, the ones that we chose from the additional databases have a very concrete reason, and this is that while the main data like forestivity, displays, and terrain info was sort of constant for some of their variables, human development index and total population adds some temporality that will be very good for the model to learn how is this crisis evolving. Then we decided which columns were we interested from each of the data sets, and basically our criteria was based on whether the information from one column was already some sort of contained in another column, and also based on the quality of that column. Say it had many nulls, we then deleted it. Also, we then merged all the tables by country and year in order to have one big compound table that contained all of these data sets. The next steps we did for the preprocessing of our data was deleting the null values we had, and this included or meant to delete some of the countries because they had very bad quality data. And so we didn't end up with all the countries that were available on the original data sets, but rather with those that had complete data. This is because the null values couldn't be compounded in any ways. Also, we applied one hot methodology, which helped us to include the name of the country so that its temporality can be counted for, and getting rid of the categorical variable of the name, and instead getting a numerical variable. Last, what we also did is to generate another data set based on this first compounded data set, for which we can have the prediction 6 years ahead for each data sample so that our model can learn from this data.
Okay, so given our data, what we wanted was to compress the information in it so that the models further on trained would perform better. So this was done because we observed that there was a bit of information sparsity, or rather many columns didn't contain much information just by themselves, and also because there were many observations. So just basically what we obtained from this compression step was a smaller vector space representation of each data instance. Then we fed those data instances, embedding representations, compressed representations, into forecasting models, mainly an ensemble of boosted trees. And that's it for modeling.
Okay, so we will move on to the results. Here we can see, for example, of 4 countries and their respective predictions for the 2025. Here we can see that for each country, there are like 3 lines, well, 3 predictions that are referring to the 3 types of refugees that exist. The continuous line is like the data present in the database, and the points are the ones predicted by our model. We can see that the results are quite good because they follow a trend, and so we are quite satisfied. Also, the added value of this work is that we have added an interpretability layer to see which were the variables that were affecting more to the results obtained by the model. So here we can see that in bold, there is the prediction of the number of refugees. In pink, we can see the variables that make this prediction higher, and in blue, there are the variables that make it lower. For example, we can see that fatalities, a lower value of fatalities make it lower, and a high value of fatalities make it higher. Also, there is the global interpretability, that is, which are the variables like generally that are affecting more to our predictions. We can see that the more important variables are the ones of fatalities, rule of law, and well, we can see here in the list. And also in the second plot, we can see that, for example, the latest is the year, the higher is the number of refugees. So this is an important point to take into account.
In conclusion, we have found that there are certain values that favor more refugees, such as secure law. We have also seen that mobility within the same country is important when there has been an event that caused a humanitarian crisis. We have also seen that there is a temporal component that implies an increase in the number of refugees as it progresses over time. And we have also managed to make a prediction for 2025. And we have also been able to analyze the results. There is still work to do after this time. We have been working, and the first would be to get the result in a more complete way, such as using interactive plot. And the second would be to improve our model with the use of embeddings or the autoencoder, because we believe that we could still get better results. That brings me to the end of the presentation, and thanks for your attention.